Okay, so this is the video clip for the first problem in the 1-2 rate of motion velocity discussion. And we're going to begin to start to use a strategy that will help us understand how to problem solve in a much more effective way, and we'll try to use this strategy as consistently as we can, so that you get used to it and that you'll always be able to use it. Only later on, after we've really learned how to use the strategy, will I let you start to not use parts of the strategy. But anyway, let's see how this works. We've got a statement that says the position of a runner is plotted as moving along the x-axis of a coordinate system. During a 3-second time interval, the runner's position changes from x1 equals 50 meters to x2 equals 30.5 meters. What is the runner's average velocity? Okay, so the strategy that we're always going to use here to begin with involves a couple of parts. The first part is we're going to write down a frame of reference for the motion as it occurs. This is going to give us a visual understanding of what the motion is that's occurring, and it will allow us to collect all of the information we need to collect in order to accomplish solving the problem. Okay, so it's very important that we begin to do this as consistently as we can. And so here's how we're going to do this. Our frame of reference, for the most part, at least for one-dimensional motion, is simply going to consist of a line that designates an origin and a direction of positive x values. That's all we need to define motion. Okay, so this is the context that our motion is occurring in. Then once we define this, we need to collect all of the information that we can. And we're going to, and you don't need to write this down yet, but we're going to follow a pattern. Always we're going to follow a pattern. We're going to collect our initial position first, although in this case the initial position is x1 instead of x0. We're going to collect our final position. We're going to collect our initial velocity. We're going to collect our final velocity. We're going to collect our acceleration, and then we're going to collect a time. And always do this in this pattern so that we don't forget information. Okay, so if I look at the problem here, my statement will oftentimes be, I don't know how to solve this problem, but I don't care that I don't know how to solve this problem because my strategy will lead me through it. You'll never be able to say, I don't know how to start a problem. Okay, because you're always going to be able to start a problem because you always know how to write this down. You always know how to do this, right? And you'll also always know how to collect the information. So my initial position, it says position changes from x1 equals 50 meters to x2 equals 30.5 meters. My initial position is x1, and I can come over here and say x1 equals 50.0 meters. Now I don't need to show where that is on the number line here. I just know that it's somewhere to the positive side of the origin. So I put x1 equals 50 meters here. That's my initial position. I also am told that my final position, x2, is to the left of that. I'm told that it's at 30.5 meters. Okay? So I have a visual representation that my motion is occurring in a negative direction, right? I'm going from a position of x1 equals 50 meters to a position of x2 equals 30.5 meters. I can see what that motion looks like, okay? Now, my next values that I need to acquire are my initial and final velocity. So there are a couple of possible scenarios here. My initial and final velocity could be different, in which case I'll have an acceleration, or my initial and final velocity could be the same, in which case my velocity is stated to be constant, or I can have an average velocity, but I don't know what the average velocity is. Okay, so I'm going to put v equals question mark here. But I will also always, for my velocity, indicate the direction of the velocity and whether or not it's increasing. Okay, so I'm just going to have a single value for velocity, right? An average velocity. It doesn't really matter if it changes during the course of the motion because we're not told any information about that. So I'm just going to say that my velocity looks like this. I'm traveling at a certain velocity in the negative direction. So when I do my math, and I find out what the value of that velocity is, it's going to have a negative value associated, meaning I am going this velocity in the negative direction. So let's see if we can make our math do that. First thing we need to do is write down our information. And we're always going to do this way. Given. What values have I been given? I've been given that x1 equals 50.0 meters. I have been given that x2, my final position, equals 30.5 meters. And I haven't been given any information about velocity. I also haven't been given any information about acceleration, so we won't write that down, although we could just put question marks if we wanted to. And I have been given information about time. I've been told that it's 3.00 seconds. Okay? Now, once I get all my information collected, I need to write down a statement of what I need. I've been told that I need the average velocity, so I'm just going to write down V for that. And then I need to create a formula that will help me find this. And since the only formulas we have so far are the only formula we have so far is the velocity formula or the speed formula, but we're asking for velocity here, I can write down that formula. I know that my velocity equals my final velocity, x2, minus my initial velocity, x1. Actually, let's back up a second and do this a little bit differently here. Let's say that my velocity more officially is delta x, okay? And the delta always means change in, and x means position, so change of or change in position over time. And then I know that that's the same thing as my final minus my initial, and change of the delta here will always be final minus initial. Wherever we see the delta, your brain should automatically go final minus initial. Okay, and so now I'm going to write down, and let me get rid of this other over here. I'm going to write down solve. That's the last step in this process. Solve V equals, and this is where I plug my values in. So my final position is 50.0 meters. My initial position, my final position, I got that backwards, didn't I? So my final position is not 50 meters. Now, why might I make that mistake? Because we're used to thinking of things further over on the right as being something that occurs later. But in our state, in physics, we can have things that occur later towards the left. Okay, so my initial position, my final position is 30.5 meters minus my initial position, which is 50.0 meters, divided by 3.00 seconds. And I'm going to bring up my calculator here. And I'm going to have $30.5 minus 50 equals divided by 3 seconds equals negative 6.5 meters per second. Okay. Equals negative 6.5 meters per second. Okay, so this is how we're going to solve every problem. We're going to start with a motion diagram, and on the motion diagram we will visually see what the motion looks like, and we will collect all of our information. Then we'll write that information down in a way that I can see all of it in one place, and then say, this is what I need, and then we'll find out, I've got a formula that will solve this. I write that formula down, and we're always going to write the formula down before we plug values in. That's just the way that we're going to do things. And then we're going to solve in this way. And so this would be how we would see this. And so for this video clip, this is what I will expect to see on your, this whole thing here is what I'll expect to see on your worksheet that you turn in. Okay? So go ahead and go to the next problem.